Good morning, dear student. Today we will discuss regarding cell or battery. You know very well, cell or battery is a source of electrical energy. That is, our reaction become a spontaneous redox in nature. When two or more cells are connected in series, known as what? Battery. Otherwise, there is no difference between cell or battery. So today, my heading is some commercial batteries. Some commercial batteries. A cell or battery is a source of electrical energy. It's convert chemical energy into electrical energy. Reaction become redox in nature. A spontaneous reaction become possible. That is, delta G gives energy changes must be negative. When two or more voltaic cell which are connected in series called battery. Some important characteristics are possible for your cell or battery. So we can write characteristic of cell or battery. The first one, it should be lighter in nature. The second one, it should be compact in nature. That is, more intermolecular forces of interaction become possible for good battery or cell. Third one, voltage should not vary appreciable during use. And last one, free from pollution. If such conditions satisfied for cell or battery, then our battery or cell should be what? Very efficient in nature. Cells or battery are two types. Types of cell or battery. First one, primary cell. Primary cell means what? In this type of cell, reaction become irreversible in nature. That is, our reaction proceed only one direction. When use completely this type of cell or battery, then cell or battery become what? Dead. Dry cell, mercury cell, etc. are the example of what? Primary cell. And the second one, secondary. Secondary means once a cell become dead, it become rechargeable. That is, our reaction become reversible in nature. Lead storage battery, or you can say nickel cadmium cell storage battery, are the example of what? Secondary cell or secondary battery. So we can write for primary cell, reaction occurs only one direction and become dead over a period of time. Reaction become irreversible in nature. You can say example what? Dry cell, voltaic cell, mercury cell, etc. And the second one, secondary cell. When the cell become dead, cell become recharged. By passing current through it. Example, you can say what? Lead storage battery, nickel cadmium storage cell. So in nutshell we can say primary cell is not rechargeable, where secondary cell become chargeable in nature. Let us consider some primary cells. That is, first number, dry cell. The following pattern of cell reactions are possible at different electrodes. At anode, zinc solid converted into zinc 2 aqueous plus 2 electron. That is, you know very well, there is always oxidation occur at anode. At cathode, MnO2 solid plus ammonium and aqueous accept one electron to form manganese oxyhydroxide. It is solid plus ammonia gas. There is always reduction occur at cathode. Anode is made from zinc and cathode graphite in this type of cell. Generally, MnO2 plus carbon touching cathode and ammonium chloride plus zinc chloride touching anode. This type of electrolytes use in dry cell. Our second one, mercury cell. Mercury cell is also an example of what? Primary cell. That is not rechargeable in nature. You can say our reaction become irreversible. The following pattern of reaction become possible. Zinc to zinc oxide and mercury oxides to mercury. Reaction proceed in basic medium. So if you balance this equation, 2H minus. Here we consider what? 2H. The oxidation occur at anode. Here we had what? 1 water. Here 2H minus introduce what? 2 electron. This reaction occur at cathode. In this type of cell, you can say anode is made from zinc, cathode graphite. HgO plus KOH moist. This electrolyte become used in our mercury cell. Our next important cell is lead storage cell or battery. This type of cell become rechargeable in nature. 4 pattern of reaction become possible. 2 reactions are discharging reactions and other 2 are charging reaction. So the next one, lead storage battery. Add anode, lead sulfate and aqueous to form lead sulfate solid plus 2 electrons. Add cathode PbO2 solid plus 4H plus sulfate aqueous plus 2 electrons gives what? PbSO4 solid plus 2H2O liquid. Anode made from Pb and cathode PbO. 38% H2SO4 used as a electrolyte. This pattern of reaction occurs when lead storage battery become discharging. The reaction of charging is reverse the reaction of what? Discharging. The reactions of charging become just opposite to charging reactions. That is, anode converted into cathode and cathode converted into what? Anode. Our next solar battery is nickel cadmium battery. At anode, cadmium solid converted into cadmium oxide. Here we add 1 water, 2 H plus 2 electron. This reaction proceeds at anode. At cathode, we can write NiOH whole twice solid except 1 electron converted into NiOH whole twice plus OH minus. You can write what? 1 electron. So, such reactions are possible when nickel cadmium battery become discharging. Here you can say anode is made from cadmium and cathode nickel dioxide. KOH aqueous electrolyte become used. When nickel cadmium battery become charging, then our reaction become what? Reverse. Our next cell is fuel cell. Fuel cell is an example of like primary cell. This cell is generally free from pollution. That's why nowadays it is frequently used. So we can write a fuel cell is a primary cell of a special type. These are the galvanic cell in which chemical energy of fuels, that is heat of combustion, is directly converted into chemical energy. Fuels such as H2, carbon monoxide, CH4, C3H8, etc. are used. That is heat of combustion directly converted into electrical energy. The following pattern of cell reaction become possible if we consider hydrogen oxygen fuel cell. Hydrogen oxygen fuel cell is an example of fuel cell. At anode, this reaction become what? At cathode. Generally, graphite electrodes are used. Aqueous KOH or aqueous NaOH. Electrolyte become used. So it is very important question for board examination point of view. The question is write short note on fuel cell, or you can say what is hydrogen oxygen fuel cell. Our last topic is corrosion. Corrosion is what? It is an electrochemical process That is, redox reaction become possible in corrosion. Generally, blackening of silver article, rusting of iron, development of green coating on copper article, etc. are the example of what? Rusting. The most important rusting is what? Fe2O3 So, corrosion is basically an electrochemical process. The development of green coating on copper, the blackening of silver article, the rusting of iron, etc. are example of corrosion. In nutshell, we can say eating away of metal into undesirable compounds by atmospheric agents or chemicals is known as what? Corrosion. Corrosion depends upon following factors: water, O2, presence of impurities, acidic impurities, that's oxide of nitrogen, or you can say oxide of oxygen, material of this substance. At last, very important concept, mechanism of rusting of iron. In rusting of iron, first of all, iron converted into Fe2. This reaction is treated as anode. At cathode, hydrogen ion accept oxygen to convert it into water. This HN comes from what? Atmospheric agent. Because you know that in atmosphere, water reacts with CO2 to form what? Carbonic acid. So finally, when we add a work to reaction, we get what? A complete balanced chemical equation. This Fe2 is less stable compared to ferric ion. That's why Fe2 converted into ferric oxide. Ferric oxide absorb X mole of water converted into Fe2O3 excess2. This is the formula of what? Rust. So finally you can remember ferrous converted into Fe2O3 and O2 converted into what? Water. In which medium? Basic medium. You get this equation. One important thing always remember, the rusting in saline water become more faster compared to normal water because saline water is very good conductor of what? Electricity. So we can say rusting of saline water become faster compared to normal water. So this is the way we can understand the mechanism of rusting of iron. Thank you.